transportation models, application of magnetic forces, PHY150 video presentation. Magnetic levitation, or otherwise known popularly or fondly as maglev, is a modern transportation technology that uses magnetic forces to lift and propel vehicles without any physical contact with the track. By eliminating friction between the train and the rail, maglev systems are able to achieve extremely high speeds while maintaining smooth and stable motion. This presentation begins with the fundamental concept of magnetism and gradually progresses towards the principles, systems, and real-life applications of maglev technology. We need to study what some of the properties of magnets are. So, magnet exhibits several fundamental properties that govern their behavior, like magnetic poles repels each other, while unlike poles attract one another. Magnetic forces act at a distance, meaning that physical contact is not required for the force to be effective. The strength of a magnetic force decreases as the distances between objects increases and is strongest at the poles of the magnet. These properties are essential in producing controlled motion and levitation in magnet systems. The concept of magnetism was discovered from more than 2,000 years ago through a naturally occurring material known as iodostone. Lodestone is a naturally magnetized form of magnetite with the chemical formula of Fe3O4. Ancient civilizations such as the Greeks and Chinese observed that these stones could attract iron and align itself in a fixed direction. These unique properties later led to the invention of the magnetic compass and laid the foundation for the study of magnetism. Every magnet possesses the two distinct magnetic poles, known as the north pole and the south pole. These poles always exist together and cannot be separated. Even when a magnet is cut into smaller pieces, each piece will still contain both a north and south pole. To date, isolated magnetic poles, also known as magnetic monopoles, have never been observed in nature. It is not possible to occur.
So, what is maglev? Maglev, which stands for magnetic levitation, and it refers to a transportation system in which trains are lifted, guided, and propelled using magnetic forces. Unlike conventional trains, maglev trains do not use wheels and therefore do not touch the track. Instead, the powerful of electromagnets allow the train to float above the guideway while electrical currents generate forward motion. This design significantly reduces friction and enables higher speed and smoother level. So, this is the history of maglev. The first idea of magnetic levitation trains was first proposed in the early 20th century with German engineer Hermann Kemper. It's introducing early concepts in the 1930s. In serious research and development began during the 1960s in countries such as Germany and Japan. The first commercial maglev system operated in Birmingham, United Kingdom in 1984 as a low-speed urban transport. And in 2004, China launched the Shanghai maglev, the world's first high-speed commercial maglev train. So today, maglev technology continues to be developed, particularly in Japan and China. So there are a few reasons why maglev was introduced. First is to overcome speed limitation of conventional rail system. Second, to reduce friction and mechanical wear caused by wheels and rails. And then to achieve smoother and quieter transportation. Next is to improve energy efficiency at high speeds. Other than that, it's helped to develop a modern, advanced transportation system for future needs. And the last one is to provide a solution for high-capacity intercity travel. So there are two main types of maglev system as were currently in use. So the first one is the electromagnetic suspension system, or it called EMS, in which the train is attracted upward toward the guideway using control electromagnets. This system will maintain a very small levitation gap and is used in the Shanghai maglev. So the second type is the electrodynamic suspension system, or called EDS, which is relies on repulsive magnetic forces produced by superconducting magnets. EDS system will require high speeds to achieve stable levitation and were used in Japan as the maglev. So this is the advantages of maglev. Maglev trains offer several significant advantages over conventional rail system. So they are capable of achieving extremely high speeds, often exceeding 500 kilometers per hour. So the absence of physical contact between the train and the track results in minimal mechanical wear, reduced maintenance, and smoother operation. And additionally, maglev trains generate less noise and vibration, so it making them more comfortable for passenger and more environmentally friendly in urban areas.
Next, I will talk about disadvantages of maglev. Despite its advantages, maglev technology also has several limitations. The construction of maglev infrastructure is extremely expensive due to the need for specialized tracks and control system. Maglev train cannot operate on existing railways line, which limit their flexibility. Furthermore, the system requires advanced technology and high energy input, particularly during startup and low-speed operation, which increases overall cost.
Based on the histogram, the construction cost increased significantly as the rail technology becomes more advanced. Metro or LRT systems have the lowest construction cost at around 8 million USD per kilometer, followed by conventional rail at approximately 12 million USD per kilometer. The cost rises sharply for high-speed rail systems, reaching about 30 million USD per kilometer. Maglev train have the highest construction cost at nearly 60 million USD per kilometer, which is about double of the cost of high-speed rail. This trend shows that while advanced rail systems such as maglev offer higher speed and technological benefits, they require substantial greater investment compared to traditional rail systems.
The next slide is maglev formula. The operation of maglev system involves several physics equations to magnetic field and electromagnetic force. These include equations describing magnetic force, Lorentz force, magnetic field strength, and electromagnetic lift. Due to time constraint, only the most important equations relevant to levitation and propulsion are highlighted in the following slide. And for the important maglev formula, one of the most important equations in maglev system is the magnetic force on a current carrying conductor, which is the formula is given by F equal to BIL. In this equation, F is represented for magnetic force, and for B is the magnetic field strength, and I is represented for electric current, and L is the length of the conductor. This equation is explained by how magnetic force are generated to produce lift and propulsion. For another key equation is the magnetic force on a moving charge, which is expressed by F equal to QVB. Here, Q is represented by electric charge, meanwhile V is velocity and B is the magnetic field strength. This equation describes how moving charge interact with magnetic field, which is fundamental to electromagnetic motion in maglev. Let's talk about the application of maglev. Maglev technology is currently used in several real-world applications. First example is the Shanghai maglev in China. It's a high-speed commercial system that connects the city to the airport and operates at speed of up to 431 km per hour. Second example is Japan SC maglev, used superconducting magnet and has achieved test speed exceeding 600 km per hour. In addition to high-speed travel, low-speed maglev systems are also used for urban transportation and research facilities to study advanced transportation
To
technology.
conclude, this presentation began with the basic concept of magnetism, starting from the discovery of natural magnet and the fundamental properties that govern magnetic behavior, such as attraction, repulsion, and magnetic field. These principles form the scientific foundation of magnetic levitation technology. We then explore the maglev and how it works, along with its historical development and the different types of maglev systems used today. The advantages of maglev, including high speed, reduced friction, and smooth operation, were discussed, as well as limitations such as high cost and complex infrastructure. Finally, a real-world application of maglev demonstrated how magnetic levitation has been successfully implemented in modern transportation systems. Overall, maglev represents an important advance in high-speed transportation by applying fundamental physics principles to solve real engineering challenges.
Thank you for watching and have a nice day.